All right, guys, we'll get started. So, 9A is short, sharp exercise. Chapter 8, we've finished. We've been looking at continuous intervals, right? We've been looking at probability distributions over intervals. Now we're going back with chapter 9. It's going to consider some of the content that we did in chapter 7, as well as chapter 8. So it sort of combines them a little bit in chapter 9. So we're going to start with what's called a sampling distribution. And so we'll just read this part together. When we take multiple observations of a random variable and add them together, we obtain a new random variable. So the example I've got here, the weight of a carton of eggs can be found by adding the weight of each egg. The length of time of a Netflix binge found by adding the length of each episode. So this is going to produce a sampling distribution, all right, that we denote with capital S. And then we've got the definition of how we calculate the mean and standard deviation of the distribution of Sn. So here we have a discrete random variable. Okay, so this is a distribution. These are the events, and these are the probabilities of the events occurring. Right, and so my events are, I can take on the value 1 or 2, and the respective probabilities of those events are 0.2 and 0.8. All right, so this is going to allow us a bit of a recap of chapter 7 for calculating mean and standard deviation. So we'll use our calculator to do it. Part A says, find the mean and standard deviation of this distribution. So what we're going to do, we're going to put it in our calculator in stat mode. This is going to be the left-hand column. This is the right-hand column. So this is recalling probability distributions. So my events are 1 and 2. And my probabilities 0.2 and 0.8. Okay, now like with a simple one like this, when you've got chapter 7 fresh in your mind, you'll be able to just do those calculations manually. But I reckon it's sort of safer generally to use the calculator because you won't make an error when we're calculating standard deviation and so forth. All right, so we've put that in our stats table. Just check our settings. So calc settings, we should have list 1 against list 2, and we'll calculate that. And I've got the mean is 1.28. I don't like that. Why is it saying that? List 1 against list 2. Calculating 1 and 2. Oh, 0.2 and 0.8, not 2. Mean is 1.8, and my standard deviation is 0.4. Okay, so if you can't remember how to do that calculator stuff, you can ask me in a moment. Let's move on. State the meaning of S10, okay? So this is the distribution of X. We're talking about the distribution of S10, which is the distribution that arises when we perform this experiment 10 times and add the results together, okay? So 10 times, that's how many times we're performing this probability experiment, and we're adding the results together. The sampling distribution is the sum of them. So S10 is the distribution that arises from 10 observations of the variable X, the experiment X. Okay, find the mean and standard deviation of S10. So we're going to look at the second grayed out box. I'll write it up here, the formula. The mean of Sn is equal to n times the mean of X, and the standard deviation of Sn is equal to the square root of n times the standard deviation of X. So the mean of S10 is going to be 10 times the mean of X, which is 1.8. That'll be 18. And the standard deviation of S10 is the square root of 10 times 0.4. And we'll state that to 3 sig figs. 1.265. 264 it should be. So that's 4 figures, and I'll round the fourth one, 1.26. Okay, so there's our standard deviation and mean of this distribution S10. We could do it for S20, we could do it for S30, and so forth. All right, state the possible values of S2. Okay, so the possible events that can occur when we take 2 observations and add them together. Now, the lowest event that we can possibly get would be if we got a 1 and then we got a 1 again. Okay, the lowest we can get is 1, and then we repeat the experiment for the second time and we get a 1 again. If we add those together, the lowest possible result is 2. Okay? The highest possible result would be if we got a 2 and then we got a 2 again. So the highest possible result is a 4, and you can see there's a number of ways that we can get a 3. So these are the possible events from the sampling distribution S2 when we repeat the experiment twice, adding the results together. And we could calculate the probabilities of these events, right? So probability of getting a 1 and then a 1 again, 0.2 times 0.2, all right? Probability of getting a 2 and then a 2, 0.8 times 0.8, and then that's going to be the leftover probability as well. All right, so it's a short, sharp, shiny exercise, 9A. That's what we'll dedicate the lesson to today, and have a little bit of time again to spend on our folio. Drafts for the folio due tomorrow. All right. Isn't today Thursday? No. Never mind. Due on Friday. Due Friday.